Let's cover problems 1, 2, 3 real quickly. How far from the base of a 5.2 meter cliff will a cliff diver land if she runs and jumps at a velocity of 18 miles per hour? I quickly converted 18 miles per hour to 7.85 meters per second using a conversion. Let's talk about what we have to do first. How far from a base of a cliff, 5.2 meters high? Okay, you know the cliff is 5.2 meters high, so you know how long she's going to be in the air for. If you know how high up she is and you know gravity, use this formula. Time is equal to 2y over a. Y is how tall you are, how high up you are, and a is acceleration due to gravity. You can determine time right off the bat. So we know she's going to be in the air for about 1 second, which is 1.03 seconds. Fine. Now, how far in the x direction will she go if she's traveling at 7.85 meters per second? She does it for 1.03 seconds. Again, distance is equal to velocity times time, and your answer is she will go 8 meters from the base of the cliff. Again, you know these problems. You did these over and over again 6 weeks ago. And these we've been doing over and over again for the past 3. Let's look at question number 2. Question number 2 is just a little bit different. It says there is a 7.5 meter tall embankment. Okay, you know how high up you are. So if you know how high up you are and you know what gravity is, you can determine how long it will take you to fall that 7.5 meters. Once you know how long it takes you to fall, and you know the distance in this direction, not the velocity, you know the distance in this direction. You know time, you know distance, what can you calculate? You can calculate velocity. This is not something intuitive. You just have to keep going over this problem 3 or 4 times, okay? Let me set this up again without looking at my paper. Try it over and over again. In this case, velocity is equal to distance over time. We have distance, we have time. How did I know how to use that formula? Well, I'm trying to find out something in the x direction. The only formula in the x direction is velocity equals distance over time. You can't use anything with acceleration because there is no acceleration in that direction. The acceleration is only downward. So again, velocity equals distance over time. Distance we know, time we know. Can we calculate the velocity needed to get you over that river? Yes, your velocity has to be 9.7 meters per second. Let's look at number 3. You would like to jump into a pool 15 meters from the base of a hotel. So you need to go farther than 15 meters. Not much farther, just far enough to get you into the pool. If you run at 22 miles per hour, I converted that, 22 miles per hour is the same as, let's see, what is that? It's the same as 9.6 meters per second. That's a conversion I made. I did that conversion before, so I didn't show it. But if you know your time, you know your distance, and you know your velocity, I'm sorry, you don't know your time. But if you have distance velocity, you can figure out how much time it takes you to cover that distance. Again, I'm trying to run and jump. I know how fast I'm going, and I know the distance I have to cover. I know how fast, and I know the distance. If you know how fast and you know the distance, it will tell you how much time. This formula will tell you how much time it takes to cover that distance. So I just found out to go 15 meters at 9.6 meters per second, it will take me 1.56 seconds to go that distance. Knowing how much time I have, that means how much time if I jump will I hit the ground. So you just throw it to the cliff formula. 1/2 AT squared. The t squared is the 1.56. That tells you how far you will drop, or once again, how far you will drop through the time. And you will drop 11.92 meters. You should be getting a negative number here. All right, negative 11.92 meters. That means you are going down in this direction. That's how far you drop. So this is problem 1, 2, 3.